So welcome students. So in this question you are given integration of pi by 3 to x root of 1 minus cos square t dt plus 0 to y square sin t dt is equal to 0. If that is so, you are asked to find dy by dx. So now you are given an equation in terms of integral and you are asked to find the differentiation. So is a question based on, so can you guess the topic? Yes, Leibniz theorem. So whenever you have differentiation of integrations, so we use Leibniz theorem. So I hope you know Leibniz theorem. So what does Leibniz theorem say? So if you have a function in terms of integral, that is integration of phi of x to xi of x f of t dt. So integral of f of t dt from limits phi of x to xi of x, because the limits are functions of x, the answer will be a function of x. And if you want to differentiate this function with respect to x, so how do you do this? This is equal to f of, so in place of t you put xi of x first, f of xi of x into xi dash of x minus, you put phi of x in the place of t, so minus f of phi of x into phi dash of x. So this is how you differentiate an integral in terms of whose limits are in terms of x. So now let us use this theorem and try to differentiate both of them. So first, if you differentiate this, okay, what is the differentiation of this? D by dx. I am applying d by dx on both sides. I am applying d by dx on both sides. So d by dx of integration of pi by 3 to x root of 1 minus cos square t dt plus, so you can see that this is a function of y because the limits are in terms of y. But if you apply d by dx here, you have to apply d by dx here. You cannot apply d by dx here and d by dy here. So let us see how to manipulate afterwards. So I am applying d by dx to both of them. So d by dx of integration of 0 to y square sin t dt is equal to d by dx of 0 is 0 because 0 is a constant. So d by dx of 0 is 0. So now this is equal to, so here the limits are in terms of x. One limit is constant, so you can think it as a constant function. So now how do we differentiate this? Let us use this. First you put x in terms of, in the place of t. So root of 1 minus cos square x into differentiation of x is 1. So root of 1 minus cos square x minus, so you put t is equal to pi by 3 here, that is root of 1 minus cos square pi by 3, root of 1 minus cos square pi by 3 into, what is the differentiation of pi by 3? 0. So whenever you have a constant limit in the differentiation, that term will become 0. You don't need to write this. So root of 1 minus cos square x into x differentiation is 1. That is the d by dx of this plus. So here also you have to do d by dx, but this is a function of y because the limits are in terms of y, is a function of y. So how do we manipulate this? So we manipulate this using the chain rule. So d by dx of something can be written as, that is d by dx of something can be written as d by dy of something into dy by dx. So this dy and dy gets cancelled, it's same as d by dx of that thing. So what I do is, so I will write it as d by dy of integration from 0 to y square sin t dt into dy by dx is equal to 0. So this whole thing is under differentiation. Now the differentiation variable is y and the function is in terms of y. Again I can use Leibniz theorem. This implies root of 1 minus cos square x is sin x plus, so how do we differentiate this? We put y square in the place of t, sin of y square into y square's differentiation is 2y minus, because it is a constant limit, the differentiation will become equal to 0. So you don't need to write that, into dy by dx is equal to 0. So this implies dy by dx is equal to minus of sin x by 2y sin of y square. So, this is the value of dy by dx. So, let us check the options. So, if you have anything like this, that will be the answer. Sorry, I have got the question wrong. Here you have 3 in the question. So, if you have 3, you have 3 here, you have 3 here. So, this does not become sin x. So, you have 3 minus cos square x here. So, the answer will be minus of root of 3 minus cos square x by 2y sin y square. Option D will be the right answer to this question. Thank you.